handheld gaming consoles are much more fun if you can hear what's going on. So let's add some sound to our Raspberry Pi Zero. Hi and welcome to Bytes and Bits. You can't really have a handheld games console without sound, and that's what we're going to be looking at in this episode. So we're currently building up a retro games console using a Raspberry Pi Zero, and the problem with the Zero is that it doesn't actually have a dedicated sound output. So we're going to have to add one of those in using our own hardware and then some software upgrades. Now there are two real ways of doing that on the Raspberry Pi Zero, and the first one we're going to look at today is using some analog sound output. So this is going to in effect rebuild the 3.5mm audio jack that you find on the full-size Raspberry Pis onto our Raspberry Pi Zero. We're also going to be adding in a little separate amplifier so that we can use both headphones or an actual speaker. Now in a second video I'm going to be looking at digital sound, which will hopefully give us a slightly cleaner output, but that is a different way of doing it which requires a different video. So if you haven't already subscribed to my channel, please do click the subscribe button so that you can get access to that second video as soon as it comes up, along with all the other videos in the channel for programming and gaming and so on. So let's get straight in and have a look at how we can add this analog sound onto our Raspberry Pi Zero. One of the differences between the Raspberry Pi Model B and the Raspberry Pi Zero is that the Model B has an audio output already connected up and on the circuit board, and we have a 3.5mm stereo jack plug here where we can plug in and get access to the sound. Now the sound is still built into the Raspberry Pi Zero, it's just we don't have the output circuitry and obviously the audio connector. So let's work out how we can add that onto our Raspberry Pi Zero. If we look at the circuit diagrams for the Raspberry Pi Model B, and especially then at the audio circuitry, we can see the output pins from the processor being fed first through a buffering stage to protect the actual processor pins. Then they pass through a low-pass filter to cut off some of the high-frequency noise, and then they're decoupled before they're being fed out to the 3.5mm jack plug. So we're going to have to recreate some of the circuitry then for our Raspberry Pi Zero. Our first problem is that the audio output pins don't appear anywhere on the circuit board. They're internal to the Raspberry Pi Zero, but we can route them to two pins on the GPIO header. So most of the pins on this header have alternate functions which allow you to use different bits of hardware. So if we look at this diagram, we'll see that GPIO 12 and 13 and GPIO 18 and 19 can both be used to bring out this pulse width modulator, this PWM outputs, which are actually the sound outputs that we need. So looking at the pin assignments I've made for this project, I've wanted to have a go at both the analog sound that we're doing at the moment and also the digital sound output. So the digital sound comes out on a number of pins that are fixed, and two of these are GPIO 18 and 19. So I've already assigned those to be free for sound, so we may as well use those two then for our analog output. So now we know what pins we're going to be using for our sound. We need to connect those up to some circuitry, which will mimic what we saw in the Raspberry Pi circuit. So I'm missing out the buffering stage and feeding the outputs directly into our low-pass filter. And with the resistor and capacitor settings there, we're getting a cutoff frequency at just under 20 kHz, which is ideal for audio. We're then decoupling it as before and then passing it on to a headphone socket. We can obviously plug a little headphones into that socket and listen to the sound through those, but I also want to be able to send it out to a speaker. So this particular headphone socket has got both an input connection and in effect an output connection. And what happens here is if there is a headphone plugged in, it sends the signal to the headphone. If the headphone is unplugged, then it reconnects the outputs, and then we can use that to feed into this amplifier and then onto an actual loudspeaker. So this final amplifier, at the moment I'm using a mono amplifier. So the two resistors let me combine the left and right headphone signals, and then that gets fed through out to a single speaker. So the next thing to do is to build all this up on some breadboard so we can plug it into our Raspberry Pi and test if this works or not. Now I've put links in the description down below to the bits I've been using. The main bit here is the actual amplifier itself. The rest are all mainly sort of passive components, but I'm just using a little simple Adafruit mono amplifier, but any one will really do. So now that we've got the hardware sorted out, we need to work on the software to get the sound driving out through our headphones and speaker. And don't forget that you can get access to the circuit diagrams and all the lists of components on the project page on my main website, and I'll put links to that in the description down below. Logging into the Raspberry Pi Zero, the first thing we need to do is to make sure that these two GPIO pins are put into this alternative function state so that we can actually route the sound signals through them. Now, one of the first things that we need to do, and something which took me a bit of a while to work out to be honest, was that our GPIO Next software, which we're using to run the GPIO game controller, that actually needs to be configured so that it doesn't interfere with what we're doing here. So the GPIO Next, it allows us to connect up buttons to our GPIO pins, and it then scans those buttons and turns them into the inputs for our game control. Now, one thing it also does is that if we don't tell it, it will affect any alternative functions that we put onto our pins. So I found that when I didn't do what we're just about to do and configure it correctly, it made the Raspberry Pi crash every time the system tried to make a sound. So the way we need to do that, if you follow through on the previous videos where we're installing it, when we run the configuration utility, we can actually get it to run that by ourselves and tell it which pins we want to use. So if we use a command, so in my, once I have the package installed, I can run this command, which runs the configuration manager, but tells it that the pins that I'm using for my controller are then this list of pins. Now, the list of pins here is the actual GPIO header connector pin numbers and not the BCM numbers. So for me, I'm using this set of pins to control my game controller. So if I ran that, that would take me into the configuration utility. And at that point I can set up my game controller and specify all the pins. But obviously I've already done that on mine. So if I come out of that, so once you've run the configuration utility, or like me, once you've already set everything up and we now need to restrict those pins that it accesses to let our sound work, then we simply need to use this command. So the GPIO Next command, and we're going to set the pins that it's going to be accessing, and again we just give it a list of the GPIO header pin numbers that our switches are connected to. So once we set that, that instructs the GPIO Next daemon, it sets its settings as it says there, to just restrict it to using those pins so that it doesn't interfere with anything else that we're doing. Once we do that though, we need to do a GPIO Next reload, and that resets the daemon, and then after that it will now look at those pins and leave everything else alone. And that means that when we change the GPIO 18 and 19 to be our sound pins, we don't get any conflict, and it does then stop it from crashing. So let's do that. And then once that's finished, we need to reboot the Raspberry Pi. So now that we don't need to worry about any pin conflicts, we need to install some sound software. So we need to update our library databases. And we then need to install something called ALSA utilities, and these are a few pieces of sound software that RetroPie will use to access the sound hardware. And again, some of these bits of software you may already have installed on your system. And the last one then is something called Wiring Pi. And Wiring Pi will allow us to both look at and control the alternate functions on our GPIO pins. So now that those are both installed, let's have a look and see the current state of our GPIO pins. So if I do a GPIO read all, so this is part of the Wiring Pi package. And this loads up a little table which tells us the current state of all of our GPIO pins. So we can see here, this two central columns are the actual physical pin numbers, so starting at pin number 1 down to pin number 40. And then apart from that, then we can see the various names, which gives us the functions, the Wiring Pi's pin numbers, and then the BCM numbers, which are the ones that we're interested in. So if we look at our two sound pins, so GPIO 18, we can see here at the moment that is in our input mode. And GPIO 19, which is down here, we can see at the moment that is set as an input. So we need these to be in the alternate 5 mode for them to be our sound pins. We can issue commands using this Wiring Pi package. So if I type in a command, so GPIO -G mode, and then pin number 18, so GPIO pin 18, and then set it to Alt 5, and I can do the same then to my GPIO pin 19. And then if I do my read all function again, we should find that those pins have dropped into their Alt 5 mode. So there we have Alt 5 and Alt 5 there as well. Now these pin assignments don't stick, so that when we reboot they will go back to normal. So there are a couple of ways that we can get these alt functions to be installed at boot up. We can use these commands that we just used, so these GPIO commands here, and we can add those into our rc.local file, our rc.local file, which of course runs a series of commands at startup. Or we can use our config file inside our boot folder, and that's what I'm going to use on this one. So again, it depends on which way around you want to do it. It's very much the same. So if we do a sudo nano, and then we need to go into our boot folder, and then it's our config.txt file. So this has a number of settings for our Raspberry Pi. And there's a couple of other ones that we do need to make sure are set in here as well. So if we come down here, again, you'll see there's a number of settings which we did for our LCD screen. So if you haven't been doing the LCD screen, some of these might not be set for you. But down the bottom here, we've actually come down to some of our sound stuff. So we have a line here, DT param equals audio equals on. So that needs to be uncommented, and that loads in the BCM 2835 driver software and enables the hardware. So if that is not turned on, you will not get any sound coming out. So sometimes that has got a little hash sign in front of it. If it does, you just simply take that out so that it becomes a proper piece of code. We then need to add in a line which will turn our two GPIO pins into their Alt 5 mode. So if we do here, so GPIO, and then we say equals, and then we give our two BCM numbers, so 18 and 19, and then we want to set those into Alt 5 mode. So that line there will then, as we boot up the Raspberry Pi, it will set those two pins to the correct mode so that they're able to take the sound signal. So let's save that. So Control X and save that. And then we'll need to do a reboot and then check to make sure that's worked. So once we're back into the Raspberry Pi, if we do our GPIO read all, we should find that our pins are automatically set into their Alt5 mode. So that's all working fine. So if you find that doesn't work for you, then do try putting those wiring Pi commands into your rc.local file in your /etc folder. But we're now ready to finish off and get some sound coming out of the system. So the first thing to do is to make sure that the Raspberry Pi is talking to the headphone socket. So if we do a sudo and run the Raspberry Pi configuration program, so inside our system options and our audio, we should be able to select our headphones. And if we say OK to that, and then tab down to finish that, so that should now be forcing the sound to come out of our headphones. And again, we'll need to reboot. So we should be ready for a sound test. So if we try this command, which is a speaker test, which will play this sound file, which just really is a bit of speech coming out of either channel.
Front, center, front, center, front.
And we should have some sound. So obviously that command, I will put that on the project page for this tutorial. And again, have a look in the links down below. And if you haven't managed to get it going, then I'll put some little troubleshooting tips at the end of this video. So please have a look there and see if that helps out. So really all that's left now is to make sure that RetroPie is able to play some sound. So if we boot into RetroPie, and then if we go into RetroPie's settings and go to sound settings, we need to make sure that we have it playing through the headphones. So if you come down here, so our audio card should be on default, our audio device should be on headphone, and just use the left and right buttons to change that around. So put that through to headphone. And then if we go down here, so sounds are on, and the OMX player audio device should be set to both. There are a range of options in here, but both is really what we should be having on that. So make sure you come out of that. Sorry, wrong button. Come out of that. And we come back here. We should now then be able to play a game with some sound. So if we go into our Atari games, let's have a look at Dig Dug. And there we have our game now with sound coming out of the loudspeaker. And of course, if we plugged a little headphone into that socket, we would then get the sound coming out through that and the speaker would turn off. So really all that's left now is to have a play around with the volume settings, just to make sure that you get everything set up the way you want. So there's a couple of places where we can set the volume, and the easiest one is actually in RetroPie. So again, if we go to our RetroPie settings and go to sound settings, you'll see we do have a volume setting there. And again, just using left and right, we can adjust the output volume from RetroPie itself. And if we log into the terminal on the Raspberry Pi, we can use something called the ALSA mixer. And this allows us to set the default volumes for various elements inside the Raspberry Pi. So you can see at the moment there, I have got the headphone selected on my system. And I can use just the up and down arrows to adjust that volume. So again, if I use the up arrows, you can see the volume increases and down arrow decreases. So I can set that to wherever I want it to be. So let's set it for around about sort of 50 or 55. And then I can exit from that pressing escape. If I want to save that, all I do is I type in a command which is sudo alsa control store, and that will then save that setting for the next time I use the system. So let's have a look at some of the problems you may come across. A big problem, of course, is that you have no sound at all, and there can be quite a few reasons why this might happen. So try working through these tips in order to see if that gets it working for you. First off, we need to check that your circuit is put together correctly. Check that your decoupling capacitors are the right way round and that you've got the correct component values. If you have got a second Raspberry Pi, try a clean installation of Raspbian with that and then plug that into your circuit. And that should check that the actual hardware is working without any software getting in the way. Now, I also found that my Raspberry Pi Zero was quite sensitive to the resistor value on the low pass filter, and that's obviously connected to each of the audio outputs. The Raspberry Pi official circuit diagram used a 100 ohm resistor, but I found if I put that onto my Pi Zero, it seemed to draw too much current from the output and caused my system to crash as soon as it started to play some sound. But if you manage to get that working and your circuit is correct, then the next thing to try out is to make sure that we actually have the output pins in the right mode. So we can use that GPIO read all command from your console or your terminal, and that will check to make sure that you have everything in the correct alternative function. So again, I was using GPIO 18 and GPIO 19, and to use those pins need to be in the Alt 5 mode. The other option was that we can use the GPIO 12 and GPIO 13, but if you're going to use those, they actually need to be in the Alt 0 mode. So do make sure you've got your correct selection of pins and the correct selection of the Alt modes. Also, I was using GPIO Next to monitor the pins for my game controller, and there are various versions of that you can use. So whatever software you're using which is going to be scanning your GPIO pins, make sure that that is not interfering with your pin assignments. And I did find on mine when I wasn't doing that, I actually got about half a second of sound before the system crashed, and that was just purely a conflict of the pin assignments. After all of that, if you're still not getting any sound, you need to check then that it's turned on in the software. So your /boot config file, make sure you have a look through that and that the audio output is turned on. You also need to make sure that the headphone output is selected in your Raspberry config configuration, and that you've actually got the volume turned up and unmuted. So have a look in the ALSA mixer code for that as well. Once you've got that set up, do make sure you try using the speaker test function on the command line, as this will bypass RetroPie, and just check that the basic functionality of your sound is working. So if you manage to get sound coming out of the command line speaker test, but it doesn't work in RetroPie, then you need to check that the RetroPie settings are correct. So go into your settings and the sound settings, make sure that it's set to play through the headphones, and make sure that you've got enough volume to be able to hear it. So hopefully if you go through all of those tests, you should be able to get some sound coming out of your system. So that will hopefully get you some analog sound output coming from the Raspberry Pi Zero. Now, I found this analog quality to be fairly good, but it wasn't great. Using a speaker with a reasonable volume setting, I got quite a bit of sort of background hiss and popping, especially when the Raspberry Pi was sitting doing nothing, when there wasn't supposed to be sound coming out. I could hear things going on inside the Raspberry Pi Zero. So the next step that I'm going to have a look at is to replace this analog sound output with a digital one. And the Raspberry Pi actually has inbuilt an I2S system, but that requires a different setup and some different hardware, but hopefully it should give a cleaner result. So I'll be doing that in a separate episode, so please keep an eye out for that. If you haven't subscribed to my channel already, please do click the subscribe button, and if you've enjoyed this episode, please have a look at clicking that like button, because every like does help tell YouTube that I'm actually making something useful in these videos. So I hope you managed to get some sound coming out, and I look forward to seeing you in the next tutorial. So bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.